Anyways, without further ado, Sean Colins.
Right on. So, hi everybody. All right, so as I said, I rewrote the vast majority of this like yesterday. So, because I wanted to add some more stuff, and I wanted it to be less dry and whatever. So we'll see how this goes. So I'm Sean Colins. If you don't know who I am, I've been next door this week, all week, introducing other people and running around super distracted by everything that you imagine happens back of house at a conference like this. I've had some amazing conversations with many of you this week, and in some cases I've asked you for your input into this subject of bash scripting and what it is to debug and troubleshoot scripts. I have a course on this subject coming out on LinkedIn Learning in a couple of months, so look for that. And I also have an updated IT admin guide to Mac OS coming on LinkedIn Learning in about a month. Please, if you do have a membership and you go and watch that, ping me. Let me know what you think of it. We've gone a different direction at LinkedIn Learning. Everyone there is really excited about this new e-learning model that they're using. It's focused around shorter movies, shorter individual bursts of content that are much more punchy, have graphics, have animations to communicate hard to understand concepts. I had a lot of fun. I got my first real animation budget in a course with the Mac OS IT Admin Guide. So if you have any question at all about how Kerberos works, there's a couple of movies in there that it's like, this moves here and that moves there, and it's really, really obvious and super easy and awesome. So let me know. Yeah. Oh my goodness. Okay, so does everybody remember lynda.com? Raise their hands. Who had or has a membership to lynda.com? Wow, that's awesome. Okay. So lynda.com was started by Linda Wyman and Bruce, her husband, right? And they sold their company to LinkedIn years ago for a lot of money. Way to go them. Like they did really well. LinkedIn got this because they realized that they're sort of this HR platform for people. People go there to put up their resumes. They go there to look for jobs. They go there to know what each other's roles are in companies and businesses and what have you. And so they wanted to have this ability to have content that they could track and you could use to track your progress through your career, right? So if you are a Mac person and you want to learn everything that there is to know about Cisco networking, you could go through all of their Cisco networking track stuff, and then now they've got assessments and they're providing their own types of certifications that can be used to track that stuff, which is really, really cool. It adds a lot of value to your LinkedIn profile. So I like that a lot, personally. Then Microsoft bought LinkedIn like the next day, right? It was crazy. It was like really, in my mind anyway, it was like really, really shortly thereafter. And so now Microsoft is doing all of their internal training, all of the recordings of their internal training, everything is done at LinkedIn Learning booths, which are all modeled after the old lynda.com recording booth kind of model. And editing and whatever. But LinkedIn Learning has taken this and they've really run with it. And so now they're producing things with much better production value. And whereas like back in 2009, I did a course where we recorded 35 hours of raw material, which was edited down to 11 and a half hours of published material in like 29 chapters or something. And it would have taken you weeks to just go through it all. And each movie was like 15 to 20 minutes long. It was crazy, right? But a real deep dive. There's a very small audience of people who have the ability to stay awake through that. And so the new model, is based on e-learning research, and it's really cool. And like I said, short, punchy videos, animations to communicate difficult concepts, that kind of thing. So thanks for asking. That's really cool. I definitely do. I love getting feedback from people after they watch stuff, especially whenever they tell me something's wrong. If you watch one of those things and you're like, oh my God, he said that completely wrong, and nobody ever caught it, that is brilliant, because I can go back in the booth and record an update, and we can publish a correction in a way that's almost invisible and makes the content right. So you have the ability to really change things for the better there. Thanks for the question. I had no idea I was going to talk about that for 9 minutes. Wow. I'm probably going to either Well, my timing's going to be weird today. So this morning, while drinking coffee and hopefully enough water, I'm going to talk through some of the things that I've learned about troubleshooting bash scripts over the years. But much more importantly, I'm going to tell you what a huge number of other people have told me are their favorite troubleshooting and debugging tips for bash scripting. As Neil has said, the slides are going to be available after, so if I don't get through all of this, you've got access to this later on. So many bits of advice I've pulled together come from people with far more scripting experience than I have. Some are a little out there, and others you may find familiar, but I hope that by the end of our time together, these tips are going to help you to set yourself up for success. I'm going to talk about useful script editor features and a couple of great text editors I found along the way researching this that I hadn't heard of before. And I'm going to start with things like logging techniques, reporting. We're going to look at a couple of really cool script editors. So the entire concept of scripting, right, is to create a well-oiled machine that automates repetitive tasks in your workflow. In about an hour, JD is going to talk about scripting in ZSH, but this session is going to talk about bash. I said that, actually, this session is kind of about scripting in general. I even talk about some concepts that get shared between programming and scripting, which are technically kind of different. A well-oiled machine would be great, but sometimes your script either just won't work, no matter how hard you try, or you have a perfectly good script that stops working unexpectedly. The goal here is obvious: get rid of the wrench in the works, right? So you need debugging techniques to help you to not only get rid of problems you've created or that have been created for you by external factors, but also to create scripts using best practices that can be followed to reduce your need for debugging in the first place. There's a lot of focus on that today. Of course, it's relatively easy to follow your own best practices if it's only you typing alone on your Mac. But even alone, if you aren't curating your code effectively, you're still going to end up with a mess within your scripts, and you'll probably also end up with a mess of scripts that are all over your hard drive. But what happens when you have a coding partner? Each of you is an independent thinker, so it's likely you're going to end up stepping all over each other. It'd be best to agree ahead of time on what your shared best practices are going to be and why you need to have best practices in the first place. Deciding on things like format, style, location, etc. can completely change the quality of the resulting work. Now imagine you're part of a large team or an extended community trying to create scripts that can be deployed in many different environments. You quickly start to see why it is so important to have best practices in place. I think it's important to start with some fundamental research into what tools are available to you. You can use any texting program to create a shell script of one type or another. I've spoken to some very smart people right here at this show who use VI in Terminal as an example, but there are plenty of graphical text editors out there that will still work great, may work better depending upon your skill set. Those would include old favorites like BB Edit, Text Wrangler, Sub-Etha Edit, but some new ones that I've recently come across include Atom and VS Code, which both can run a color scheme overlay called Monokai Pro that's really cool looking. VS Code and Atom are both a quick Google search and a download away. I definitely recommend you take a look at them, try them out. Shell scripts require special formatting, and most importantly, that there are no hidden characters within the document. Most of us know this if we scripted before. This, of course, means not using text edit in RTF format, right? But you can go further than that, of course, by using a text editor that is intended for scripting. Text editors are intended for coding, and those will have, text editors that are intended for coding will have support for various programming and scripting languages. Many of these are going to support code completion in languages like Python and Ruby, but will also support scripting language such as Bash, ZSH, and CSH. The nice thing about these is that when you start to type a command that is a known Bash command, the text editor will suggest things to autocomplete for you, easily allowing you to avoid typographical errors and also speeding up your scripting once you get used to it. When you start to enter something that the text editor recognizes, the text editor just shows you the option that allows you to select it by autocompletion, and this is a great way to shortcut through a lot of typing and avoiding some typing errors. So this one seems a little obvious, but I thought this was a really interesting idea to communicate. It came up in a course that I was taking on something completely unrelated over the summer. Sometimes you see things more easily if you just change your perspective on the problem, right? This has less to do with choosing a text editor than it does with knowing how to manage code blindness. Code blindness is kind of a fatigue syndrome that programmers, scripters, but I mean, really any type of writer and content creator will experience when they've been looking at the same set of material for way too long, right? Sometimes just resizing the text in your editor can help you to see your code better. When you've been staring at the same block of code for hours or days, it can be useful to have someone else review your work. But frequently, you may need to play tricks on your eyes to make them see everything in a new way. This could be especially true with scripting because sysadmins rarely have a colleague who will have the time, maybe, the inclination perhaps, or even the skill to review your work. Simply changing the formatting or the size of the text can reveal mistakes that are right in front of your face. Resizing the text in your script temporarily is a surprisingly effective way to make code blindness go away. In many text editors, simply selecting the entire document and pressing Command+ will increase the font, and Command- will reduce it, right? You can make a change in font sizes and preferences too, of course, where you can specify how different types of code are formatted, but those changes are going to affect current and future documents you work on, which may not be what you want to do if you're just trying to resize text for a quick perspective shift. You'd never expect that changing font size would make you a better troubleshooter, but try it out the next time you feel like you're just not seeing that mistake in your script that you know is there. When your script gets sophisticated enough to start building conditional statements and functions, your script can become quite long. It can be hard to read your entire script easily without scrolling around on screen. This is something that came up when I was talking to a colleague at LinkedIn Learning who's taught a huge number of Bash scripting courses. His perspective on this is a Bash script is not intended to be very long. In contrast, application coding leads to programs, right, with incredibly lengthy and complex interconnected and interdependent files. Bash scripts should never be as complicated as a program would be, right? For this reason, the tools that are available to you within Bash to deal with a lot of lines of code are not as robust as those you would encounter in something like Python or Ruby. That being said, a good text editor will allow you to set up sections of code that can then be collapsed to free up additional screen space. Collapsible code in a script editor allows you to shrink functions into smaller spaces on screen, making it easier for you to keep track of what you're doing. When a Bash script becomes too large to keep track of visually, you've probably reached a point where you should shift to a different language like Python or move to a programming language and look at possibly even building an application instead. Whatever you choose, when a Bash script is so long that you're losing track of what's going on, you may want to move your project into some different environment that is better suited to larger projects. So this demo was recorded in Sublime Text, which is one of the really full-featured text editors that I found while asking colleagues about their favorite tools. You can see here as I roll my mouse pointer over different conditional statements, Sublime Text is allowing me to collapse the if statements in on themselves to make the code easier to look at. In a small script like this, the effect is minimal, but on large, complex scripts, having the ability to collapse functions and conditional statements can be immensely helpful. Color coding, different types of text within your script, allows you to know by color where different parts of your script begin and end more clearly. You don't have to use a professional programming tool like Xcode on macOS to write Bash scripts, though you can. But if you do choose to use a professional level tool like that, or many of the other ones that I've mentioned, you're going to get great features like color coding within your scripts. Color coding is a fantastic troubleshooting tool because you can easily keep track of what is going on in your code. A simple visual cue can help you to quickly identify places in your code where you may have made a mistake that would cause your script to behave unexpectedly. So let's assume you've chosen a text editor that automatically color codes your script for you and also supports automatic text completion. I recorded this example here to show what color coding looks like in a script, but also how autocompletion works. I recorded this in another product called Atom. Note that I'm just selecting existing commands in the script, deleting them, and I'm just sort of showing how this works by typing them again to show that the system is making the suggestions for the commands to be auto-completed. Every script writing professional or hobbyist needs to hold on to their work, right? You build a library of scripts that you've written over the years eventually, and being able to find things later on can be very helpful. To do this, you've got to establish a library location somewhere at the outset. A script library is simply a repository you hold onto that contains the work you've done, right? But a good script library can be much more than just a folder with a bunch of text documents. Options for archiving scripts should include the following options. A script library should be organized by the functions the script is written to perform. If you have a script that is going to bind computers to Active Directory, for example, that script should be organized with all of the other scripts that you have that bind computers to directories. If you have scripts that set up printers or create new administrative users or whatever, those scripts should be organized accordingly. Another very good feature of a script library is the ability to share your scripts with others so that the community that you work within can benefit from each other's experience. This doesn't mean that you should put your scripts on every message board in every community that you participate in. Doing this can be helpful to others and it's useful and you should do it, but it doesn't equate to a shared library, right? GitHub is it's really the standard for sharing code publicly and offers some great features for sharing, iterating code, and collaborating on it. Most everyone I've talked to about this at the show already stores content up on GitHub. Just curious about what this is going to be. Hands up for everybody who has a GitHub account. There you go, yeah. Lastly, I do want to point out that if you don't do anything else, at a minimum, you should absolutely set up a folder on your computer where you organize all of your script examples for later retrieval. This may seem obvious, but if you don't choose to use an online resource like GitHub, or if you don't set up a local Git repository to hold your scripts, don't just give up on the idea of organization, right? At a minimum, organize everything in folders on your computer and organize the folders named after things that your scripts can do. Who here has ever used a style guide in publishing, like to just write like for a magazine or something? Okay, I love how much creative background there is in our community. That's fantastic. Who here has used a style guide to organize how they do scripts in an organization? Okay, so I was actually the only one. I was really surprised. I knew about this from the publishing industry. I started my work in technology in the publishing industry. I was really surprised when researching this that there are organizations that have published style guides to indicate how scripts should be written. People have already given a lot of thought to the question of how a script should be written and formatted, and in many cases, there are great guides on what styles to follow. Just giving you a for instance here. Have you ever been in a shared Google document and found that you're writing with one set of goals in mind and one writer and one writing style, and another person is trying to accomplish something different with the same document and writing with a completely different style? It just doesn't work. Both people end up pushing and pulling each other in different directions, resulting in a bad document that doesn't accomplish the intended goal, and it takes much too long to collaborate. If everybody in that shared Google Doc had the same rules to write with and everyone agreed to work together in lockstep, you could accomplish a lot more. That's the value that style guide adoption can bring to you and your team. There are a couple of great style guides out there to consider. If you write in an environment where lots of other people collaborate with you on projects, say for example in a large enterprise organization, where there are many systems administrators who access and write scripts in a shared repository, it's going to be important for you to follow a style guide so that you write your scripts in the same way that you can interact efficiently without having to rewrite or reformat each other's code. Working within an adopted style guide in an organization allows everyone involved to write to one consistent style. This avoids lots of problems, including how things are commented, how functions are called out, how math is dealt with, and other elements that might be written in different ways but need to be consistent. Style guides are available from several solid resources, including the ones I've placed into the slides here from GitHub and Google. Of the two, I was reading through the one on GitHub, and I think I like it better, but you know, look at both. It's a relatively small task to distribute a style guide to your entire team, and for everyone on the team to use that style guide so that they're coding in a coordinated and efficient manner. So, just writing a script isn't enough, right? It has to run to do anything. And for it to run, you have to set specific parameters on the script file itself. A script must be executable in order to run, and it must be executable by the right account. This rule is simple but incredibly important. I can't tell you how many times I've been working on a script or I've delegated script writing to someone else, and when it came time to run the script in the middle of some time-crunched engagement, the script doesn't run. Everybody has to stop what they're doing and start troubleshooting what's going on. We look at all of the various reasons why it might not run. We troubleshoot, we frequently forget to look at the most basic things, like the permissions. We forget to look there because it's so well known by everybody that nobody thinks that it would ever be forgotten. But oddly enough, that's exactly the reason why people tend to forget it. It happens a ludicrous amount of the time. It's not part of scripting per se, but it's fundamentally critical to the execution of the script. All scripts must be owned by the user that have to run the script, right? So what does that mean? If your script must run with root access, for example, you know that the root or system user needs to be the POSIX owner on the file, and that user must have executable permissions on the script file. If your script requires that a logged in user execute or have the ability to launch your script, you would likely set the POSIX group of the script to staff, which is a group that includes all available users on the system and would allow the staff group the ability to execute the script. You would not give everyone else in the world the right to execute the script, of course, nor would you on any script most likely. But that being said, it's common to find recommendations from third-party software vendors that include 755 permissions or a 775 recommendation. So let's review what that means, just so everybody's on the same page. Read equals 4, write equals 2, execute equals 1. We add these numbers together based on the permission that we want to apply, and the result is the number that represents the level of access. For the owner, which is the first number in that 755 octal notation, the owner has a 7 permission, which is just 4 plus 2 plus 1 equals 7. So the owner can read, write, and execute the file. The group has 5, which is 1 plus 4, which equals 5, so the group can read and execute. And everyone else who may encounter the script gets the same 5, so we're done. This is a handy chart in case you need to reference the numbers ever. I've long used calculators to do this, but it's easy to memorize. It's just a laziness thing. There we go. File system paths at the command line and in scripts can be a super pain, right? Scripts and command line executables cannot handle spaces in file and folder names. So when you type a path to a resource at the command line, a space is interpreted as a break in the argument. The command expects a line return, or maybe another switch or flag, but instead it gets the next word in the file path, and it doesn't know what to do with that, indicating to the shell that the space should be ignored, or more accurately, that the space should be incorporated into the file path, can be accomplished in one of two ways. First, you can choose to use a backslash when a space is about to happen that is actually a part of the file system path. The shell will interpret that backslash as an escape of the space. The result will be that the command will not break the argument. The other way to escape space in a path is to enclose the path in quotes, which indicates to the executable that everything between the quotes is one argument. I find the quotes works better for me, mostly because I can see them better than the backslash, but both work equally well, and you should choose to use the one that works best for you. The one thing to remember is always escape spaces and file paths at the command line and in your scripts. If your script is failing mid-run and you have paths and the files in there, better go double check them and be sure that you haven't missed a slash somewhere. So, case sensitivity. Sometimes case sensitivity can be an issue right down to the file system level. macOS supports 2 case-sensitive file systems, but one thing that may prevent you from utilizing what you believe to be a well-written generic script that should function across multiple operating systems is that some systems may be case-sensitive. Your cross-platform script might technically work on Linux and macOS, but may fail to work because of incorrect capitalization when typing file names or paths to resources. There are a couple of ways of handling this. First, it does make sense to write a script that is platform-specific and just keep it organized so you can find it easily and deploy the right script to the correct platform. That works. But even if you do have a generic script that will run on macOS and Linux equally well, you may as well keep one for each OS in your script library so you can be sure the one you are about to use is the right one for the job. Linux tools create case-sensitive folder structures by default. macOS has APFS case-sensitive and macOS Extended Journaled case-sensitive as options that you may find, though those are rare in the field. Windows systems will preserve case, but they won't allow you to have 2 files with the same name except for the case in the same location, which is, of course, what case sensitivity is. The takeaway here is assume case sensitivity is present when typing paths and so forth, but you don't have to assume don't assume case sensitivity if your script is creating files on the file system. Type case if you anticipate it to be in the target OS, And then, even if you're writing for a case-insensitive file system, write your scripts matching the case of the letters you anticipate to be present in a case-sensitive file system. If the script runs on a case-insensitive file system, it won't care, and if the file system is case-sensitive, you've dealt with one more possible point of failure, making your scripts less likely to need troubleshooting in the future. Also remember, in a case-sensitive file system, two files may have that same spelling in the same location, but have different letter casing in the name, and they'll be treated as different files. It can be easy to lose track in those conditions, so be aware. So what if the problem isn't your script, right? Testing your concept in real life is so important. Sometimes you're trying to do something, but you may be assuming that thing is possible when it may not be, at least not under the conditions where you're deploying your script. In these cases, you can run a full test of what you think should work, but in the GUI of the target system under anticipated target conditions, so you know whether your workflow can be done at all. It's important to know what is possible before proceeding to automate it so you know where your failure truly is. Check your assumptions. Have you ever tried to do something in a script and you know the script is written properly, but for whatever reason, the thing you're trying to do fails and you really just can't figure out why? I've noticed that it can be really helpful to try to do the thing that I'm trying to accomplish using tools that exist in the GUI so I can validate that the operation I'm attempting works. For example, if I'm trying to set up a printer on a network and the printer won't set up, the script keeps failing and I don't know why, it can be helpful to go to the computer and test setting the printer up through methods other than my script. You can, of course, use other methods as well. For example, you could SSH into the remote system and ping the printer's IP address to see if the computer can route requests to the device. You can check network configurations. But generally speaking, if a graphic user interface provides you with the tools to do something, you can do whatever that thing is and determine if what you're trying to do can't succeed at all in that environment. If it can't, that'll lead you to further troubleshooting steps, but it'll guide you away from trying to troubleshoot a script that may work just fine. In this example, things that might fail would be the printer is simply not turned on, or maybe your computer and the network, your computer and the printer are on different networks that don't route to one another. Of course, the example of binding computers to Active Directory serves as a good example too. If you were running a script to bind to Active Directory and the script failed, it could be that your script was written perfectly well, but the computer that you're running it on can't find the Active Directory primary domain controller. It's an easy thing to validate. On a Mac, if I wanted to bind to Active Directory, I would just go to Directory Utility, attempt to bind the computer. If it doesn't work in the environment where I intend to deploy the script, then there's something else wrong that has nothing to do with my script. All of this is just to say, sometimes troubleshooting your script may involve troubleshooting other aspects of your environment in order to come up with a solution that functions well. Challenge your assumptions. It's not always going to be your script that's in the wrong. Let's talk about commenting. The pound symbol is interpreted by the shell as a line of code that should not run. We use the pound symbol to not only keep certain lines of code from running when a script is executed, but also to place real language text descriptions in line with our script contents to explain exactly what we're trying to accomplish. This may seem obvious, but many of us go through our day-to-day administrative tasks rushed, behind schedule, and under pressure. And under those circumstances, the last thing you're going to do is take the time to properly document your work. You're much more likely to write your script and troubleshoot your script until you get it working. Once you get the script to work, you're going to use it, and you're going to have meetings, and documentation is just frequently going to end up the lowest priority. What I'm advocating here is either take the time to comment your code while you're writing it, or be disciplined enough to go back after your deadlines are up and properly document your code by adding comment lines above and below lines of your script to indicate that what each line is attempting to do. There are many good reasons to do this. First, you're writing your scripts and you know what you're trying to accomplish, but nobody else does. If you ever have to hand your scripts over to the next person who has your job, or if you ever become the manager of the department you're working in and you need to hand off your work to someone to delegate aspects of your job, it'll take you forever to explain to other people what you were trying to accomplish in the script if you don't have proper commenting in place. Also, I don't know how good your memory is, but I don't remember what I was trying to do in every line of every script I wrote 10 or 15 or 20 years ago. Whether you need to remember or you need to transfer knowledge to someone else, commenting of code is really the only way to do this effectively. It is most effective to, it's most effective to create comments at the very top of the script and explain what the script is intended to accomplish from beginning to end. It's also a best practice to provide comments for every conditional statement, function, and in some cases, every line of code that accomplishes a single task. It's also useful to indicate within your comments not only what that section of code is trying to do, but also to define executable functions and flags that you're using so that people who don't understand the commands you're using will have an easy, immediate reference for the work that you've done. If you do this effectively, and everyone else does this as well, the incredibly rich body of work that's available and posted to the internet will be much more useful to everyone who has the opportunity to download and reuse other people's work. This is more useful because commenting allows people to learn from examples. It is nearly impossible to learn from other people's examples if only code is present and no comments are available. The takeaway here, comment everything, be descriptive, and please be specific. So in the same vein as commenting, a changelog is an important step to take. I don't see changelogs in a lot of people's scripts. I know I didn't start using them until recently. Show of hands, of those who do script now, who actually uses changelogs really consistently?
Does Git count?
No, not in this context, not in a bash script. Well, because that's a great way to track iteration, but well, let me go through this first, and it'll be clear. So, a changelog is important to any script that is written and remains in production use over time. It's useful to comment your changelog and iterate, right? So, to that, yeah, GitHub would be great. Right, absolutely. But bear with me. Scripts start innocently enough. You have a small task you feel you can automate. You want to use scripting to your advantage to automate your work and make your life more efficient. Bravo. That's the whole point. That's what we're doing. But then we realized that we could have done something a little bit better. We realized our script would have been a little bit more functional if we added a line here or if we add another line there. Maybe a new operating system requires a slightly different way to do things, and so we modify the script again. Keeping track of all the changes that you make can make referring to earlier versions or understanding the evolution of the script much easier. When writing a change log, it's a good idea to add a date and time for each note changed, and then to be as descriptive as possible about what you've changed, about whatever the old script did, and how it did it, and why you changed the new functionality. Sometimes leaving the old script text in as commented code can work as well, can be helpful to somebody that's coming back in and trying to reverse engineer where you've been. Just remember not to reference line numbers in your change logs because as you add more comments to the top of your script, obviously the line numbers in those various commands will roll down and will change as things move down. So I don't have this in a note and I don't have this in a slide, but I want to address that. So the kind of change log commenting that I'm talking about, and the reason why it came after the thing on commenting, is that I'm proposing that you put your change log into the script itself as commented code at the top of the script, right? This can get lengthy, and I would never suggest doing this if you were coding in like Swift or something, right? Because that would get crazy because it's many, many files, large projects. But with a bash script, which is generally intended to be a shorter script thing, writing all of the comments right up there in the top of the script. It doesn't matter where it goes. It doesn't matter who gets it. It doesn't matter how they get it. They're always going to have access to that change log, and they're going to know, what came before. That's kind of the point. Earlier, I was talking about the differences between scripting as an individual or scripting in a large distributed environment. We talked about style guides and that sort of thing in order to try to get everybody moving in the same direction. This kind of goes to that, right? If you are going to distribute your script to people who you may never even talk to, this is a great way to give them that additional information. And that's the point about the commenting code section of this presentation in general. It's really easy to find great scripts that do what you want to do on the net, right? Like you can Google it, you can find it, you can tear it apart, you can rebuild it, you can do all kinds of things. But if somebody's gone to the trouble of commenting their script to a really detailed level, you just read and you know exactly what's there. You know exactly which parts are doing what. You can take things apart. You can learn a lot faster. So this is just as much about training the next generation of scripters, the next people coming into the community, as it is about keeping track of things for yourself, right?
Whenever I download a script from the internet, I'll always put the URL where I got it from in a comment at the top.
That's a great best practice. Oh, God, that's another point, and I'm just going to say it now because I'll totally forget to say it later. I got to get on a flight later today, and I'm only going to be here for about half the day. Anybody that's got something that they were like, God, I wish you would have said this, find me afterwards and tell me, because I'm super, super interested in filling in more details on this topic. So where am I? Here we go. So Bash. I've only got 14 minutes left. Okay. Bash runs code sequentially, so it's very important to set your variables up top and then call them further down in your script. A variable is a temporary store of information. There are two kinds of variables I want to mention here. One, system variable. This is information that's available to a script, which will be passed through with symbols that we use and reuse, right? Sometimes we will write scripts that automate things that we know how to do so that we can hand those scripts off to other systems administrators that don't, right? Then they don't have the scripting talent to do everything that we've scripted. They don't really understand the contents of the script, but they have enough talent to change a variable at the top of the script and run it, right? This happens a lot. When we do this, we'll define variables that the system administrator running the script or the user of the script can modify at runtime in order to create a customized experience. A script sometimes needs to know information about your network, your environment or a directory services path or something. Other things that the script would not be able to derive automatically. So we define them as variables at the top of the script so a system administrator can get into the script, make a couple of quick changes, and prepare it to run. Define all those variables at the top of the script and comment before each and every one of them so that it can be very, very clear about which one needs what type of data. Make it foolproof so that anyone could run them. You could also ignore variables entirely and expect a system administrator to know where to insert user modifiable data into the body of your script. I have seen this happen. The results are never pretty. It's never good. Always remember, just because you know how to do something does not mean everyone who has the ability to open your script will also know how to do the same things or will even be able to research how to do them. Make sure that you provide solutions that will not cause more trouble than they're worth when those solutions are distributed to other people. So when you refer to or read a variable, you use the $ before the variable name to indicate that it's a variable to the system. When you set the variable at the top of the script, you omit the $. When you run the script, variables are replaced with whatever the variable represents at runtime. Let's talk about functions briefly here. A function is a basic programming concept that you can also leverage in scripting. You'd make a little script within your script that you can call over and over again as necessary. As you do this, your final script may look like just a long list of function calls, which is why it's so important to organize your code as we've discussed before. Because your script is actually going to be a combination of all your functions, it's important to keep your function calls all in one chunk at the bottom, running in an elegant sort of streamlined process. So this is something that I first learned. Bless you. This is something I first learned whenever I started to poke around in Swift. In scripting, you can do the same thing. You can write a function that does one thing, and then you call that function later on so you don't have to write that code over and over and over again. In programming, this can result in a very simple program with a lot of different functions where the functions are written above, and then at the bottom you write a simple program that just calls the functions in a specific order until a task is completed. I found shell functions defined as follows. A shell function is an object that is called like a simple command and executes a compound command with a new set of positional parameters. So by creating and calling functions, you reduce the likelihood of errors in your script because you're limiting the number of times you have to retype complemented lines of commands. So this is one where I put the link into the slide, and I anticipate you'll go and review this a little bit. This is, so diagramming flow control to test your logical expressions is a helpful way to understand what is happening when you run your script. You can shorten the amount of time you spend debugging your code by testing your logical expressions outside of your script. This is a Stack Overflow article linked that is a useful exploration of that idea. It's recommended reading. I'm not going to get into it here, but I did want to make sure that you had the resource. So I keep using the file path idea as an example because it's easy to understand. The idea being that if you include a space in a file path, it'll break the argument, and the system will stop running the command you intended prematurely. But bad file paths are not the only thing that can break an argument. An argument could be simply broken by not following the correct syntax of a command, or failing to enter an expected flag or an important bit of data. For example, if a command to mount a file share requires a username and password to successfully complete, and you pass the username flag, but not the password flag, the command will fail because you didn't give it everything it needed to finish running. So it just stops dead in its tracks, looks at you funny, not really, but you can just imagine it, right? Like a golden retriever sitting there looking at you as if to say, what are you doing? You know you're supposed to be petting me right now. If you have code that needs to run and you issue the wrong flag, or if you issue the wrong result of a flag or the wrong input after a flag, you will break your argument. We've also talked about how these broken arguments are easier to find if you choose a text editor that has color coding associated with pre-assigned functions. So if you're typing a script that's trying to filter network traffic to find IP addresses, and you're piping those IP addresses out to a text file or something, you can easily break that argument by simply failing to enter the correct number of spaces, or entering the incorrect flags, or leaving out anything at all that should be in there within the argument. When troubleshooting, just remember to look closely at your script for arguments that may be broken. They're easy to fix, but they're also easy to create and overlook. So a colleague suggested that a best practice is to put echo statements inside of conditional statements so that your script echoes out to the operating environment each time it completes a step. In Bash scripts, commands run sequentially. The first line executes first, then the next line executes, etc. Sometimes in a script, a line can't execute until a condition of some kind is met, and that's when you use conditional statements like if-then statements, if-then-else statements, elif statements. Conditional statements are used where if only one property exists, then the script does one thing, and if it doesn't exist, then you do something else. It can be very helpful to identify these branches with an echo statement. This is similar to the concept of commenting out your code to explain what you're trying to do with each line of code, but the difference is by echoing out what you're trying to do, your script will print out in terminal or in log files what you want to know when each of these branches is met, encountered, and acted upon, and which choice was made. In a script with multiple conditional statements, it can be very useful to see output that indicates where the script is when it's failing. This can help you to go back to your script to troubleshoot the very specific parts that are failing, rather than staring blankly at the entire script wondering why the whole thing failed. Logs are incredibly useful in troubleshooting. You can write your script so that the script kicks out a log that you can use and your users can use in troubleshooting its operations. Similar to echoing a statement that tells your system what part of the script was running with when your script failed, you can also type out and put into a log file for the same purpose. If you have failing functions within your script, try running them on your own to see where a failure might be. You can always pull a function out and run it independently. Sometimes your variables are just written wrong. So if you go through your script and you take out variables in your troubleshooting and replace them with the literal code, sometimes that can help you to find errors. Math and Bash. Okay, so math in Bash is a little fuzzy. Bash doesn't understand higher math skills. It only functions with integers. So if you have a complex number that you need to calculate using functions in Bash, you're really going to need to be sure that only integers are included in the math function. If you need to do math that is more complicated in your script, the only real way to accommodate that need is to go to a completely different programming language like Python. There is a BC plugin for Bash that can do slightly more complicated math functions, but you can't depend on that plugin being present on all systems that might run your script, so it's not a best practice to depend on them as a systems administrator unless you have 100% complete control over what is on each system that you expect your script to run on. We have plenty of fantastic courses. Oh, sorry, that's a different line. There are so many excellent help sites out there. So everybody knows about the Mac Admins Bash channel in Slack, right? And we have Jamf Nation out there as well. There's a ton of great examples of scripts to use out there. I was talking to people from Adigy out in the room yesterday, or the day before that, and they were showing me their scripting capabilities within Adigy. It's very, very robust, some really great things, and they've all got great resources for learning. Of course, Stack Exchange is fantastic. So programmers and systems administrators succeed because they're lazy, right? Who's proud of being efficiently lazy, right? It's not a bad thing in our line of work. It's actually a sign, it's a good thing, because if you're efficiently lazy, it means you're not going to just sit there and do repetitive tasks over and over again because you can, because you're billing time, right? You want to get your job done as quickly and efficiently as possible, so you're going to find ways to automate stuff. So aggressively go out there and find other people's scripts, right? Read the excellent commenting that they provide, because they're going to be really, really good at commenting, because they know that you're going to be finding their scripts so that you can figure out what they figured out already, so you can add to your skill set, because that's how we're all learning, right? Learn from other people's work. It's one of the best ways to set yourself up for success and not have to troubleshoot your scripts down the road. If you don't know what command is appropriate to do what you want, there is a command intended to help you find commands. And this isn't necessarily in scripts. This is, in terminal command line, you would use this to find things to do something you want to do. So say you've Googled it and you can't find anybody else's script to do something. You're looking for a command to do some specific thing. Apropos is a simple program you can use by typing apropos into terminal, followed by a keyword that you believe will be related to a command that should do what you want. Want a command to help with printing? Apropos print. What returns is a very long list of possible commands that you need to then filter through, and the available options, and you can find things that you think might be good candidates. Read the man page on the command in question, and then use what you found. Want a command to help with network traffic? Apropos network. Same thing. Search, identify, research, use man, move on. Want a command to configure LDAP? Apropos LDAP. Want a command to set up remote access via SSH? Apropos SSH. I mean, it just goes on and on. So what if you've never used man before? No problem. By passing any command through man, you will get executables. You will get the executables man page, if one exists for that command. A page of all the useful information about how to use man is available by typing man in a terminal window and reading the man page on man. That gives you many pro tips for managing man pages. So a man page includes a description of the command, flags that you can use to modify it, and in many cases, very useful sample usage at the bottom of the page that can be super helpful. We talked about using a code repository like GitHub. Sign up if everybody here raised their hands, so I don't even need to read this. You guys are all there. So resources. Moving forward, this is GitHub, Scripting OS X, Armin Briegel. Anybody ever watched one of his presentations? Armin's fantastic, isn't he? He gave a presentation at MacTech recently, didn't he, in Sweden? Really, really good stuff. His site is fantastic, scriptingosx.com. He made a very funny comment about the naming convention of the operating systems. He's basically like, I'm not giving up my name. Apple can call Mac OS whatever they want to call Mac OS. I'm keeping Mac OS X. It's pretty cool. So these are all very useful learning tools that I would definitely recommend you check out. And I'm exactly out of time, so thank you very much.